Okay, and should be live. Check my YouTube streams and stuff. Yep, I think it looks good. Cool. Just checking a thing. Yep, looks good. All right, welcome back. And I've been saying we're working on Wi-Fi this week, and I ended up busy with other stuff until today. So let's take care of that. The story is that by the way, I'm kind of multitasking here because I have to do a thing on the laptop to get started. But the story here is basically that Wi-Fi on these machines is a mostly standard Broadcom chip running full Mac firmware, which Linux already has support for. But there's some weird Apple things going on. For one, it's a different variant of the chip that needs a few changes to the driver, but those are pretty minimal. Um, but the main thing though is that Apple has um, quite a few different firmwares that can be used depending on which machine you're on. But also specifically, they have a huge number of NVRAM configs. And so the challenge isn't so much getting the driver to work, it's figuring out how to arrange this in a way that Linux can automatically pick the right files to use on any given machine. Because what we don't want to do is what the patch that's been floating around for a while now is doing, which is it requires users to manually pick out the right firmware file for their machine and all that. And like that's just not good. This needs to be something that just is seamless, right? So just clicking that. So I'll show you in a second because I'm just fixing up my Mac right now because it was I had installed Mini during a test yesterday because I was fixing up something else and I need to disable that because this is on macOS 12.1. To can show you the firmware files from macOS. So give me just 1 second. I'm doing this on the side. Uh, the easiest way to uninstall Mini when it's on top of macOS is just switching back to reduced security. So hopefully that works. Doing the update now. And yeah, so basically the goal today is going to be adding code to the Asahi Linux installer that will take the firmware files out of ideally the recovery OS image, because that's something we are installing, so we know the version and it's going to be static. We want anything to be consistent, and then my plan is to rename all the files and do like a big sort of file management switchover to simplify things a bit, because you'll see in a second, there's a ton of files. A lot of them are the same. There's some symlinks involved. And, we could just copy the whole tree the way Apple has it and have the Linux driver work with that. But that just doesn't feel right to me. So, actually, let me show you what it looks like on Linux. Yeah, so these are the Broadcom firmware files on Linux. And there's not that many of them. And that's also one of these sort of not great things. This actually doesn't support a lot of hardware. And specifically, what I mean is that these Wi-Fi chipsets are intended to have configuration files specific, not the firmware, but the configuration files specific to the like antenna configuration for a given board, right? And that's usually done properly on embedded systems. But here, as you can see, we don't have that many variants of these TXT files or the NVRAM configs. So we have some Raspberry Pi stuff and a few others, and that's mostly it. And so what ends up happening is that a lot of people run Wi-Fi with sort of generic configs that aren't optimized for the specific board they're running, and then they find that performance sucks, or the range is bad, or all of that. And that's because you need to use the right configuration for your hardware. And so you'll see that Apple has a ton of those. I don't know if they ship that many configs for real, but they definitely have the files for them. So let me see if I can SSH. And I'll show you what it looks like on macOS. Actually, let me do it here. Oh, it's fine here. Actually, don't need to be root for this. I think this is actually user lib somewhere. User share, user standalone firmware, maybe. Yeah, not quite. These are not the Wi-Fi ones. Where was that? Also, why is this so slow? Son? I think it's probably doing something dumb. And the battery is dead, which probably doesn't help performance. Wow, that is slow. Yeah, of course. I think OHD helper is Spotlight. Turn that off. Yeah, everything's turned on. Of course it is. Prevent Spotlight from searching these locations. Root. How about that? Hey, I think it shut up. Maybe. Well, now MDS source is using CPU. Anyway, see, this is one reason why I want to get Linux on these machines, because you can turn this kind of crap off on Linux or just not install it to begin with. But anyway, so where was the firmware? I forgot actually. I remember there's some called antennas were called like X1 or something. Is that a user? No, it should be a user. Or like A1. No, where was that? Broadcom thing. It should be. I forgot where that was. It's not a user. Hold on, just Google it. It should show up under the T2 stuff because it's the same story there. Where's the files? It is in user share. Oh, user share firmware. That's where it is. Okay, yeah, Wi-Fi. Okay, yeah. So this is what we have. So we have a bunch of platforms. And which apparently are named after islands, interestingly enough. And so these actually, I think, don't have that much interesting stuff that we care about. But the important stuff is that if we look at these subdirectories are for specific chips and revisions. And then inside we have the actual firmwares, which are TRX files. And you can see that in this case, we actually have one dimension for the firmware. There is the generic firmware, which is symlinked in some cases, and then there are the ones with these things appended, and these are the antenna IDs. And so the antenna ID is specified in the device tree, and I guess represents the specific antenna configuration. So in this case, they all share the same firmware, which is usually the case. And then there's no other dimensions from the firmware. So any specific platform will use the same firmware for that given platform. Now here's the more interesting part. This is the NVRAM config. Oh, there's another thing, by the way. There's the CLMB, which is I think the regulatory data, and that's the same as the firmware. That just has the antenna config in there, which is kind of weird. But then we have the TXT files, and so these are the NVRAM. And you can see that a lot of them are symlinked, but not all of them are. And in particular, a lot of these are the same, right? You can see the size is the same, and those are actually the same. And so what we have is the full naming scheme for these is antenna config, then the module ID, I guess, the vendor, which is one character, and then the module version. And so the interesting thing is that unlike on Linux, which usually just have the chip ID and the platform you're running this for, on macOS we have a lot more dimensions to work with. I think this is the Apple Silicon one that all these Macs have. So we have, RASP VU. That's the one I remember. So the first thing is sort of figuring out what we're going to do with all this. And my plan is I'm going to write a script that basically looks at these directories and builds a list of files and sort of arranges them as a like having a tree of properties, right? Of dimensions. And then what we're going to do is like prune branches of the tree. So we look at everything under a given branch, and if they're all the same, or at least we find the majority, if we have the majority of them are the same, then we can have replace that branch with like basically add a file that doesn't have that dimension and delete all those files. And that will simplify a lot of this because as you can see, most of them are symlinks. And then the driver will have to basically look for firmware files in increasingly less specific naming. And so that I think is more of a reasonable way of doing this. So let's open up Kate and do a little bit of sketching out what I want to do. I should probably open a new session for this because this has nothing to do with Linux itself yet. And now it takes forever to close everything. So actually, if we the total number of files in here is like is pretty big. It's like 1,300 files, right? So you can see why I want to get rid of that. Yes, I know. Yeah, that's one thing I don't like about Kate. I don't know why it does this. I should file a bug for this. When you save a session that has a bunch of unsaved, untitled files, and then reopen it, it just reopens a bunch of empty, untitled files, which is completely useless. So, yeah. So let's fix this. And the firmware copying stuff is obviously going to work also on Intel Macs because it's all the same. So it's going to be part of our installer, pulling it from the recovery image on Apple Silicon Macs. But I also want it to be a standalone script you can just run on Intel Macs to pull the firmwares and basically do the same thing. And in fact, then there's going to be a mechanism for that firmware to be automatically copied to Linux. And there's no reason for that not to also be used on Intel Macs. My plan is to copy the firmware to the EFI partition as a tarball, and then have distributions automatically untar that basically on libfirmware. And so, if we do it that way, then basically you would just run the script on Intel Macs on macOS. It would do all the right things, and then you would reboot into Linux, and Wi-Fi would work. So, in principle, I can debug this on Linux too, because there's nothing Mac specific about this. So let's do it like that. So first let's sketch up a little bit of the naming scheme that I want to use. So we have these dimensions, and actually on top of this, there's the chip name. And that's another issue, is the revision numbers here, and I don't actually know how they map to the hardware. It's not exactly the same in... You can see some of them have like C2 and nothing, A0 and nothing, but then I looked at the driver, and like the way that is looked up is a little bit weird. So it's also not clear if that's consistent or not. But basically that's the macOS naming scheme. This is the Linux naming scheme. Just kill that. And you can see that some of them are like symlinked to Cypress, which is a different story. Because you know, they think they bought this division from Broadcom or something. But so the Linux model is Broadcom FMac, for example, 4387. And let's say we have the C2 in there too. And it would BCI for these. These are all BCIe .bin. So the bin file would be like this, but because we can actually have these are going to be in principle Apple specific firmwares. We wouldn't want to call them the generic firmware Linux is going to use. So we'd still want to have the manufacturers. Then you can see that the way the naming scheme works here is it's a period and then the maker name, comma, and then the model name. So this would be .apple.bin. But in this case, because the antenna config is part of this also, we want to have two files, two possibilities, right? And in this case, only the first one would exist. The antenna config in this case is, like X0 or something. And then the CLM blob would be the same. And by the way, this is also recently introduced to the driver. There's a thing for using different firmwares for different makers, I think. But we still have to change the way these are looked up because it's not going to be the same as it's not gonna be the same as the ones on PCs. So we are going to do something like that for the firmwares, and then the NVRAM is where it gets interesting, right? Because we need Apple, and then we need all the dimensions for the different parts of the firmware. So I don't think I want to tag them because that's a bit annoying. So it would be Apple, comma Shikoku, and then I think just dashes will work, or something like that. So it'd be Shikoku, and because the antenna is sort of a separate dimension. If you look at these files, in general, all the antennas are sim-linked to the same things for the module versions, but I think that's not always the case. Not necessarily. Um, and so I definitely want to get rid of the antenna dimension first. But then you can see there's also other dimensions here. But I also don't want, if there is an antenna like config that varies. Let me see if there's any configs that vary. Actually, antenna configs. X2, those are sim linked. Those are sim linked. Those are sim linked. So it'll look pretty much the same. Um, Three, yeah, those are sim links. I think I saw some that weren't sim links. Yeah, those are sim links. X3M, interesting. Okay, maybe not. Maybe all the antenna configs are the same. But I also wouldn't want to rely on that because they, obviously they have that as a dimension here. What I'm basically wondering is whether I want to make the antenna config a sort of separate pruning in the substitution, or whether I just want to have it as one straight thing. It's looking like we might be able to just have the antenna config as the final branch, and that will actually work. I think so, yeah. That looks like it's probably a good idea then. It simplifies things a bit. Okay, so then what I would do is say, and the firmwares, right, hold on. The firmwares do have the platform name, so that's important. Sorry. PCI Apple, and this would be like Shikoku X0. So we'd actually have three. There wouldn't be just Apple firmware. Probably no, we would want to do that. So then we'd have three lookups for the firmware, right? And three lookups for the CLM blob. And then for the NVRAMs, we would have Shikoku rasp m 6.9 x0.txt. And then what I would do is prune, because these are usually the same. And you'd end up with that. So they would be looked up in this order, basically. And so the goal for today is write a script that takes this firmware tree and turns it into something in this format that then we can ship and stick it in like a tarball that we can use to automatically copy it from macOS. So first, let me first copy this all over. And this is 12.1, so let's call it like that. Am I going to copy everything? Yes, I'm going to copy everything. We have to copy everything because think about it. You might want to boot that root file system on a different machine. And like I mean, I guess if you are copying it on every boot, then you could copy it from the boot partition on every boot. But that doesn't make a lot of sense the way you usually do firmwares on Linux anyway.